again, this is reviewing, a lot of this is reviewing what we did on Friday. We would find the values of 6 trigonometric ratios using unit circle. In much of this unit circle we did on Friday, we said that x, y is the same as cosine theta sine theta. And I think Friday we said x equals cosine theta and y equals sine theta. Okay? And we didn't draw all of this in, but we talked about it. Okay? So if you want to add it, go ahead. If not, that's okay. Can I move on to the next slide? Anybody not ready? Okay, moving on. The largest possible value for sine and cosine. The largest possible values for sine and cosine are 1. Okay? This ordered pair right here was 0, 1. This ordered pair here is 0, -1, and so the largest value for sine, the y value, is 1, and the smallest possible value is -1. For cosine, this ordered pair was 1, 0. This ordered pair is -1, 0. And so the very largest possible value for cosine, the x value is 1, and the very smallest possible value is -1. So what we're saying is the values of cosine and sine will circle around between 1 and -1 constantly. Okay? At some point in this semester, we will draw the graph of a sine wave and a cosine wave, and we call them a wave. Not to get into it all right now, but we call them a wave because they look like this. Kind of like sound waves or waves of an ocean or a lake or anything like that. And so the possible largest value would be a 1, and the possible smallest value would be a -1, and that wave would just fluctuate between 1 and -1. Okay? So, find the sine of 150 degrees. And so if we draw 150 degrees, this red angle right here, the reference angle to that terminal side is 30 degrees. And if we look at a 30-degree angle, the opposite is 1, the hypotenuse is 2. And sine is the y value, and y in this quadrant is, this quadrant right here, y is positive. So it's going to be 1 over 2. Okay? So what we did on Friday is we said, hey, these are all going to be the same as quadrant 1, except some are going to be positive and some are going to be negative in these other quadrants. Okay? Now I'm saying, hey, if you don't remember that, you can always refer back to 30, 60, 90. Notice that that 150-degree angle is the same as this 30-degree angle. And look, bless you, look at the 30-degree angle. It's opposite over hypotenuse. And so we get 1 over 2. And then just make sure that you remember in quadrant 2, y is positive. So it's going to be positive 1 over 2. Okay? Cosine of 135. In quadrant 2, cosine is negative 135 degrees. The reference angle would be 45. So if we look at a 45, 45, 90, like right here, cosine is adjacent. So adjacent, this 45 is 1, and hypotenuse is square root of 2. And we said cosine's negative, so we get negative 1 over square root 2. And if I rationalize, that's what? Negative square root 2 over 2. And if I need to see it, I left room here. 1 times square root 2 is 2. Square root 2 times square, I'm sorry. 1 times square root 2 is square root 2. And square root 2 times square root 2 is 2. So my answer is negative square root 2 over 2. Okay? Just showing you another method other than memorizing. Okay? Any questions on that? Okay, moving on. Circular functions. Functions defined by using the unit circle, such as sine and cosine, are circular functions. For other trig functions that can be defined using the unit circle are tangent, cotangent, secant, cosecant. I'm going to pause so you can copy this down, then we'll talk about it. Okay. Four other trig functions that can be defined by using unit circle. Tangent, remember the ratio for tangent is opposite over adjacent? And if I'm looking at this little right triangle here, and here's my point, and this angle is theta, then this side is x, and this side is y. That's how we get the ordered pair x, y. Would you agree with that? Okay, so tangent's going to equal the opposite, y, over the adjacent x. All right? And so the tangent is y over x. Now we said cosine theta is equal to x, and sine theta is equal to y. And we also said that secant is the reciprocal of cosine. So the reciprocal of x is 1 over x, right? And we said sine is y, and cosecant is the reciprocal of sine, so it's going to be 1 over y. And of course, cotangent is the reciprocal of tangent, so this is going to be the reciprocal of that. Right. Again, trying to wrap up some loose ends that we talked about, but maybe not quite specifically enough. So, do you have any questions on any of these? All right. Moving on then. We're not always on the unit circle. Our radius is not always 1. Okay? So these 6 rules apply when the radius is not always 1. So if we look back at this for a moment, we said sine was y and cosine is x, and then we have our tangents and secants and cosecants, cotangents. In those cases, let me go back. This was really x over 1 because the radius, the radius is 1. That meant the hypotenuse was 1. If I look at this circle here, if my radius is 1, then my hypotenuse is 1. And so the only difference between these 6 rules and the other 6 rules is that the radius is not 1 in this case, and so some other number. But the sine of the angle is still y over the radius, in this case, whatever it is. And the radius is found by the square root of x squared plus y squared. In other words, using Pythagorean theorem, right? If we go back up here, there's this statement right here I meant to comment on, and I forgot to. Several of these values are undefined. What makes them undefined? When the denominator is 0. And so, for example, tangent of 90 degrees, right here, tangent of 90 degrees, the x value of a 90 degree is 0. And so we can't find the tangent of 90 degrees. If you try it on your calculator, it'll give you an error message. Okay? So it's undefined. Or maybe it'll tell you it's undefined depending on your calculator. All right? So any questions on this? I think. So today, we're going to work on 15 through 43. I don't know if you realize it, but we're always doing the odds, because the odds are the answers that are in the back. Okay? And so you have access to the answers. But we're doing 5, 3, 15 to 43 odds. Some of them will be quick, some of them not so quick. You have quite a bit of time to work on them, and hopefully you'll get done or almost done.